This video addresses several problems with a guide for installing under-cabinet lighting. The guide presents several safety concerns. The guide suggests drilling a hole directly over the outlet. This is extremely dangerous as it can damage electrical wires and create a fire hazard. The guide does not emphasize the importance of wearing proper safety equipment, such as gloves and safety glasses. The guide exhibits a lack of clarity and detail. The guide does not provide specific measurements or instructions for drilling the hole and attaching the light fixture. This lack of detail could lead to errors and incorrect installation. The instructions for identifying the neutral wire are unclear and insufficient. The guide is missing information. The guide does not mention the type of drill bit to use for the hole or the recommended size of the hole. It does not specify the type of screws or fasteners to use for attaching the light fixture. The guide does not provide any troubleshooting tips or advice in case of issues during installation. The guide uses outdated techniques. The guide recommends using a hammer and screwdriver to knock out the back of the electrical box. This method is outdated and could damage the electrical box or wires. Modern drywall boxes typically have knockouts or pre-punched holes that should be used instead. The guide shows inconsistencies. The guide initially states that the light strip can be plugged into an existing electrical outlet, but later instructs to hardwire the fixture. This inconsistency could lead to confusion. When dealing with electrical installations, it is crucial to prioritize safety and accuracy. This involves understanding electrical codes, using appropriate tools and materials, and following safe work practices. Here are some key aspects to consider. Firstly, electrical codes and regulations. Electrical work must comply with local and national electrical codes such as the National Electrical Code, or NEC, in the United States. These codes provide detailed requirements for safe electrical installations, including wire sizing, circuit protection, grounding, and wiring methods. Familiarize yourself with the relevant codes before starting any electrical project. Secondly, safety precautions. Always turn off the power to the circuit you will be working on by switching off the corresponding circuit breaker or removing the fuse. Use a voltage tester to verify that the power is off before touching any wires or electrical components. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. Thirdly, wire selection and sizing. Use the correct type and size of wire for the application based on the circuit's ampacity and voltage rating. Refer to NEC Table 310.15. B16 for allowable ampacities of insulated conductors. Ensure that all wire connections are made properly using wire connectors or terminals that are listed for the application. Fourthly, circuit protection. Install circuit breakers or fuses of the correct size to protect circuits from overloads and short circuits. The circuit breaker or fuse rating should not exceed the ampacity of the smallest wire in the circuit. Fifthly, grounding. Properly ground all electrical equipment and appliances to provide a path for fault current to flow back to the source, which helps to protect against electric shock. Use a grounding conductor of the correct size and connect it to the grounding electrode system. Sixthly, wiring methods. Use approved wiring methods for the type of installation, such as non-metallic sheared cable, electrical metallic tubing, or rigid metal conduit. Support and secure wiring properly to prevent damage or strain. Seventhly, electrical boxes. Use electrical boxes of the correct size and type for the application. Ensure that all box fill requirements are met as specified in NEC section 314.16. Eighthly, making connections. Make all wire connections inside electrical boxes using approved wire connectors or terminals. Ensure that all connections are tight and secure. Ninthly, testing and inspection. After completing the electrical work, test the circuit to ensure that it is working properly and that there are no ground faults or short circuits. Inspect all connections and wiring to ensure that they are secure and properly installed. Tenthly, working with a licensed electrician. If you are not comfortable performing electrical work yourself, or if the project involves complex wiring or code requirements, hire a licensed electrician. A licensed electrician has the training, experience, and knowledge to perform electrical work safely and in compliance with code. In a specific case of installing under-cabinet lighting, there are several additional factors to consider. Firstly, fixture selection. Choose under-cabinet lights that are suitable for the application and that meet all safety standards. Consider factors such as light output, color temperature, and energy efficiency. Secondly, mounting location. Determine the best location for the under-cabinet lights to provide adequate illumination without creating glare or shadows. Mount the lights securely to the underside of the cabinet using appropriate hardware. Thirdly, wiring method. Decide whether to plug the lights into an existing outlet or to hardwire them into the electrical system. If hardwiring, use the correct wiring method and follow all code requirements. Fourthly, switch location. Determine the best location for the switch to control the under-cabinet lights. Consider using a switched outlet or installing a separate switch in the wall. Fifthly, dimmer control. Consider using a dimmer switch to adjust the brightness of the under-cabinet lights. This can help to create a more comfortable and energy-efficient lighting environment. In addition to these considerations, it is important to be aware of some common mistakes that people make when installing under-cabinet lighting. Firstly, using the wrong type of wire. Using the wrong type of wire can create a fire hazard. Always use the correct type of wire for the application, based on the circuit's ampacity and voltage rating. Secondly, making loose connections. Loose connections can cause overheating and electrical problems. Ensure that all wire connections are tight and secure. Thirdly, overloading the circuit. Overloading the circuit can cause the circuit breaker to trip or the fuse to blow. Do not exceed the ampacity of the circuit. Fourthly, failing to ground the equipment. Failing to ground the equipment can create a shock hazard. Properly ground all electrical equipment and appliances. Fifthly, ignoring code requirements. Ignoring code requirements can result in unsafe and illegal installations. Always follow all applicable electrical codes. By following these guidelines and taking the necessary precautions, you can safely and successfully install under-cabinet lighting in your kitchen. However, if you are not comfortable performing the work yourself, it is always best to hire a licensed electrician. They can help ensure that the installation is done correctly and safely, and that it meets all code requirements. Under-cabinet lighting offers numerous benefits. Firstly, improved visibility. Under-cabinet lights provide task lighting for countertops, making it easier to see while preparing food. Secondly, enhanced aesthetics. Under-cabinet lights can enhance the look of the kitchen by highlighting the backsplash and countertops. Thirdly, increased safety. Under-cabinet lights can improve safety by illuminating dark areas and reducing the risk of accidents. Fourthly, energy efficiency. Under-cabinet lights can be energy efficient, especially if they use LED technology. LED lights consume less energy than traditional incandescent lights, which can save money on electricity bills. Fifthly, versatility. Under-cabinet lights are versatile and can be used in a variety of applications, such as kitchens, workshops, and home offices. They can be mounted under cabinets, shelves, or even on walls. When choosing under-cabinet lighting, there are several factors to consider. Firstly, light output. Consider the amount of light that the fixture produces. Light output is measured in lumens. Choose a fixture that provides adequate light for the task at hand. Secondly, color temperature. Consider the color temperature of the light. Color temperature is measured in Kelvin. A lower color temperature, such as 2700 Kelvin, produces a warm, yellowish light. A higher color temperature, such as 5000 Kelvin, produces a cool, bluish light. Choose a color temperature that complements the decor of the room. Thirdly, energy efficiency. Consider the energy efficiency of the fixture. Choose a fixture that is Energy Star certified. Energy Star certified fixtures consume less energy than non-certified fixtures. Fourthly, size and shape. Consider the size and shape of the fixture. Choose a fixture that fits under the cabinet without being too bulky or obtrusive. Fifthly, dimming capability. Consider whether the fixture is dimmable. Dimmable fixtures allow you to adjust the brightness of the light to suit your needs. In addition to these considerations, it is also important to choose a fixture that is easy to install and maintain. Look for fixtures that come with clear instructions and that are made from durable materials. With the right under-cabinet lighting, you can improve the functionality, aesthetics, and safety of your kitchen. Just remember to prioritize safety and consult a qualified electrician if you are not comfortable performing the electrical work yourself. Electrical safety is paramount when working with any electrical system or device. Understanding basic electrical principles, recognizing potential hazards, and following safety precautions can help prevent accidents and injuries. Firstly, understand basic electrical principles. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Ohm's law states that the voltage across a conductor is proportional to the current flowing through it, where the constant of proportionality is the resistance. The formula for Ohm's law is volts equals amps times ohms. Power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. The formula for power is watts equals volts times amps. Secondly, recognize potential electrical hazards. Electric shock occurs when a person comes into contact with a live electrical circuit. The severity of the shock depends on the voltage, current, and duration of contact. Electric shock can cause muscle contractions, burns, cardiac arrest, and death. Electrical fires can occur when electrical circuits overheat or when flammable materials come into contact with live electrical components. Electrical fires can spread rapidly and cause significant damage. Electrical explosions can occur when flammable gases or vapors ignite in the presence of a spark or arc. Electrical explosions can cause serious injuries and property damage. Thirdly, follow electrical safety precautions. Always turn off the power to the circuit you will be working on by switching off the corresponding circuit breaker or removing the fuse. Use a voltage tester to verify that the power is off before touching any wires or electrical components. Never work on electrical equipment while you are wet or standing in water. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. Inspect electrical cords and equipment regularly for damage. Replace damaged cords and equipment immediately. Never overload electrical circuits or extension cords. Use extension cords only temporarily and unplug them when not in use. Keep electrical equipment away from flammable materials. Never tamper with or modify electrical equipment. If you are not comfortable performing electrical work yourself, hire a licensed electrician. In addition to these general safety precautions, there are also some specific precautions that should be taken when working with under-cabinet lighting. Firstly, use the correct type of wire. Use the correct type of wire for the application, based on the circuit's ampacity and voltage rating. Secondly, make sure the connections are tight. Loose connections can cause overheating and electrical problems. Ensure that all wire connections are tight and secure. Thirdly, ground the equipment. Failing to ground the equipment can create a shock hazard. Properly ground all electrical equipment and appliances. Fourthly, follow the manufacturer's instructions. Follow the manufacturer's instructions carefully when installing under-cabinet lighting. This will help to ensure that the installation is done correctly and safely. By following these electrical safety precautions, you can help to prevent accidents and injuries and ensure that your under-cabinet lighting is installed safely and correctly. Remember, electrical work can be dangerous, so it is always best to err on the side of caution. If you are not comfortable performing the work yourself, hire a licensed electrician.